Ever wondered how functions work in C++? Well, you're in the right place. Let's dive into the world of functions in C++. Think of functions as the building blocks of any C++ program. They encapsulate a block of code that performs a specific task. This encapsulation makes your code modular, meaning it's broken down into smaller, more manageable pieces. Not only does this make your code easier to read and debug, but it also allows for reusability. You can call a function as many times as needed, which saves you from having to write the same piece of code over and over again. Now, let's talk about the structure of a function in C++. A function consists of three main parts: the function signature, the return type, and the function body. The function signature includes the function name and any parameters the function might need. The return type defines the type of value the function will return, and the function body contains the block of code that will be executed when the function is called. Let's look at a basic example. Consider a function named add that takes two parameters, a and b. The purpose of this function is to return the sum of a and b. The function signature is int add, int a, int b. The return type is int, and the function body is return a plus b. This function is declared before our main function, and its definition, where we specify what the function does, is provided afterward. To use this function, we simply call it in our main function, passing in the values we want to add as arguments. The function then returns the sum of these values, which we can store in a variable and use as needed. So that's the basics of functions in C++. They help us make our code modular and reusable, ultimately making our lives as programmers a lot easier. But remember, with great power comes great responsibility. As we dive deeper into functions in the next scene, we'll explore how to use this tool effectively and responsibly. Stay tuned. Now, let's dive a little deeper into functions. The landscape of programming is vast and full of exciting concepts, and functions are no exception. They are like the building blocks of a program, each performing a specific task. And when we put these blocks together, we have a complex system ready to solve real-world problems. But how do we create a function? Well, in C++, it's a three-step process. First, we declare the function, then we define it, and finally, we call it. Let's break it down. Consider a simple arithmetic operation, like addition. We can create a function for this. We start by declaring the function with the keyword int, followed by the function name add, and then in parentheses, we put our parameters a and b. This gives us our function signature. Next, we define the function. We open the function body with a curly brace, and then we write the task we want the function to perform. For our add function, we simply return the sum of a and b. We close the function body with another curly brace, and voila, we've defined our function. Finally, it's time to call our function. We do this inside the main function. We create a new variable, result, and set it equal to our add function with the numbers we want to add passed as arguments. Now, every time we call our add function with two numbers, it will return their sum. So, in essence, a function in C++ is a self-contained block of code that performs a specific task. It's declared with a unique name and can take parameters. The function is then defined where the task is coded. Finally, the function is called to execute the task. This modular approach makes our code more manageable, reusable, and easier to understand. It's like having a toolbox full of different tools, each designed to perform a specific task. And when we need to perform a task, we simply call the tool we need, and it does the job for us. And that's how we define and call functions in C++. Simple, isn't it? Now let's shift gears and explore an interesting concept called recursion. Imagine a series of Russian nesting dolls. As you open each doll, there's another one inside, smaller yet fundamentally identical. This is the essence of recursion in programming, a function calling itself over and over each time with a slightly different argument, until it reaches a condition that signals it to stop. So what is recursion exactly? It's a technique where a function, instead of doing its job from start to finish in one go, splits the job into two parts. The first part is a small chunk that the function can handle right away. This is called the base case. The second part is the remainder of the job, which looks suspiciously like the original job, just a bit smaller. This remainder is passed back into the function. This part is called the recursive case. Let's illustrate this with an example, the factorial function. In mathematics, the factorial of a number is the product of all positive integers less than or equal to that number. So the factorial of 5, for instance, is 5 times 4 times 3 times 2 times 1. In a recursive function to calculate the factorial of a number, the base case would be if the number is 0 or 1, in which case the function returns 1. The recursive case is when the function calls itself with the number -1 and multiplies the result by the number. The function continues to call itself, reducing the number by 1 each time until it reaches the base case. The beauty of recursion is that it allows us to solve complex problems by breaking them down into smaller, more manageable problems. It's like taking a big, intricate puzzle and solving it piece by piece until the whole picture comes together. And that's the magic of recursion, solving complex problems by breaking them down into smaller, manageable chunks. Ready to dig a little deeper into recursion? Let's go! Let's revisit our factorial function. Remember, it's a recursive function, meaning it calls itself to solve a smaller instance of the same problem. In the case of our factorial function, the smaller problem is calculating the factorial of the number -1. So, when we call factorial of 5, the function in turn calls factorial of 4, which calls factorial of 3, and so on. This sequence of calls continues until the function encounters the base case, which in our example is when the number equals 0 or 1. At this point, the function returns 1, and the sequence of recursive calls begins to unwind. Now you might wonder what happens if the base case is never reached. Well, that's where we encounter one of the potential dangers of recursion, the risk of infinite loops. If the base case is not properly defined, or if it's never reached due to some error in the function will keep calling itself indefinitely. This is similar to getting lost in a maze where every path you take leads you to a place you've already been, and you can't find the way out. In programming terms, this is called a stack overflow, and it can cause your program to crash or behave unpredictably. But when used correctly, recursion can be an elegant solution to some complex problems. It allows us to break down a problem into smaller, more manageable subproblems. Each subproblem is a simpler version of the original problem, and solving these subproblems ultimately leads to the solution of the original problem. So, to sum up, recursion in C++ involves a function calling itself with a smaller instance of the problem. It's a powerful tool, but like any tool, it must be used with care. Always make sure to define a base case that the function will eventually reach to avoid infinite loops. And that's how we use recursion in C++, an elegant solution to some complex problems. So, we've covered a lot today about functions and recursion in C++. Let's take a moment to summarize the key points we've learned. Functions in C++ are powerful tools that allow you to encapsulate specific tasks within your code. They consist of a function signature, which includes the function name and any parameters, a return type, and a function body. This structure provides a clear and concise way to organize your code, making it more readable and maintainable. By using functions, you can make your code modular, meaning you can break down complex tasks into simpler ones, and reusable, allowing you to use the same block of code in different parts of your program without having to rewrite it. We also explored recursion, a technique where a function calls itself to solve a smaller instance of the same problem. Recursive functions are especially useful in solving problems that can be broken down into simpler subproblems. They have a base case to stop the recursion and prevent an infinite loop, and a recursive case where the function calls itself with a smaller value. This process continues until the base case is reached, at which point the recursion stops. So why are functions and recursion important? They make your code more efficient, easier to understand, and more maintainable. Functions help break down a program into manageable units, making it easier to debug and improve. Recursion, on the other hand, provides an elegant way to solve complex problems by simplifying them into smaller subproblems. In essence, functions and recursion are not just tools, but essential building blocks in writing effective and efficient code in C++. The more you understand and use them, the better your coding skills will become. Remember, practice is key in mastering these concepts. Keep experimenting, keep coding, and you'll see how these powerful tools can transform your programming journey. And that's a wrap on functions and recursion in C++. Keep practicing, and you'll be a pro in no time.